done a little bit of research of our own that we would like to share. But as we seek to translate academic research toward industrial applications, we have a few questions that maybe this audience can answer. So first of all, I want to say that we are humbled by the amount of research that has been done over the decades. And even if we just focus on legislation, regulation, and policy rules, there have been languages, standards, ontologies, meta-ontologies. But putting on my hat as an entrepreneur, not just a computer scientist, my first question when I enter a new domain has to be, who is the customer? This gets to a discussion that we started having at the end of the previous LegReg workshop. And we started asking questions about, like, what are the requirements, what are the features and benefits, what are the use cases, right? How do we project manage this thing toward actual revenue at some point? And that's starting to sound like the language of Silicon Valley, where they ask these questions all day long. And where we, in these rooms, we talk about ontologies and semantic extraction and compliance-oriented reasoning, Silicon Valley talks about legal tech, reg tech, and sup tech, which I just learned about. It turns out it's not going for a late-night poutine, it's supervisory tech. Has anybody heard about supervised sup tech? Okay, apparently it's a thing. So I was reading an article about sup tech, and they were talking about which governments are using which technologies. And the row that jumped out at me was this one, machine-readable regulations. And as of July 2018, apparently nobody was doing anything there. But the people who wrote the report apparently felt so strongly about this. They were like, well, we just have to have that row anyway. And maybe that'll encourage someone to do it.
There's two in the report.
So let me switch gears and show some of the work that we've done. We've talked about the work that is going on in Australia and New Zealand, the better rules. And the people there have been converting entitlement legislation that looks like this into a system called OpenFisca, which is basically Python, and it looks like this. And that powers a public API, which is pretty awesome. And citizens can go and type in things and get their answers. But this is still what I call an example of analog to digital conversion. And whether you're doing it by hand or using some sort of natural language processing tool, I feel your pain, because it's not easy, especially when you have to deal with input that looks like this. In actual legislation, this is one sentence that's over 1,000 words long. Go feed that to your NLTK, right? And this looks just like object code, right? This is a compiled binary, basically. And when you try to turn object code back into a high-level language, you're reverse engineering it. You're basically writing a decompiler. I think that's what a lot of us have been doing inadvertently. And when you were 9 years old, right, did you say, when I grow up, I want to be a statutory interpretation reverse engineer, right? No, you didn't, right? You said, I want to be a lawyer, and you had no idea what you were getting into. And so I want to suggest a better way, right? Instead of analog to digital, as Carl said, let's do digital to analog. And that is what isomorphism means to me, right? This is the holy grail that we talked about. This is the approach that they champion in New Zealand and Australia. And so I took that piece of legislation and I drafted it into our language, which looks like this. And the amazing thing is, right, this actually compiles. This is an AST, but it compiles into this output, which is isomorphic to the original text. And I believe that this is useful, right? This is once you can do this, so it's pretty awesome. Because word for word, right, the code turns into the text. People have been talking about isomorphism for a long time, and I haven't really seen anything beyond Attempto or ACE rules that really goes in this direction. So you can turn it into English, you can turn it into mathematical algebra, you can turn it into YAML for a test suite. You can use it to explain how you arrived at the answer. And so maintaining support for isomorphism in our contract language and our rule language is one of our two big goals. We've got another big goal, which is support for formal verification, static analysis, or model checking type things. And so this is basically the plan that we have, our research agenda that I'd like to put in front of you. And when we get into our flipped Q&A, this is something maybe we can talk about. We want to, inspired by PostScript and SQL. We want to design and develop a DSL for the kind of thing that we care about. And that DSL should have explicit support for natural language generation, and it should have support for formal methods so that you can sort of push it into your SAT solver and say, this law has a loophole, or this contract gets into an undefined state if you have this event trace. And of course, this has to be open source, it has to be an open standard, because we care about, I mean, if it's public law, it should be open, right? This is the sort of thing that Carl Melleben talks about. So that's the plan, and we would like it to be interoperable. I'm betraying my IETF background. Interop is important. We want it to be interoperable with some of the popular languages that are out there today. And to do this, I believe it's not just the two of us that are going to get this done. We will need a team of researchers. We probably need to put together a research group. And one of the questions I have for the audience is, how big of a group and how much time do we need to do this, right? Like how many people does it take to make PostScript or SQL? So how long will it take to turn research into something that 10 years from now, right, lawyers, law firms, but also non-lawyers and non-law firms will be using? I think the inspiration is what spreadsheets do for quantitative reasoning, something new needs to do for qualitative reasoning. Building that tool will take some time. I'm hoping to get your advice on how to go about doing that. So that's my 5 minutes.
Excellent.
You okay?
Thank you very much.
All right.
Let's give all of our panelists a round of applause.